There's anyone who would like to pay physically today? Our stall is near the water filter and you can pay them.
The Bilatat set. That the Bilatat set.
Water filter. Can pay.
Mal Vamanat set. Mal Kadanat set. Ah, Kelatat set. Balu Petio set. Speed usage lifestyle उपकरणों set. SLT mobile home 4G. Hammer famous set.
Super high speeds, ultra low latency, a steady connection that keeps outperforming. The most stable internet connection. SLT Mobitel Fiber. Fastest, most stable, unstoppable. Super high speeds, ultra low latency, a steady connection that keeps most stable, unstoppable. Super high speeds. Super high speeds, ultra low latency, a steady connection
Attention, please. This is an announcement for the OC members who have been assigned to each team. Uh, all the OC members are required to go back there to receive instructions from him before the next session. Attention, please. This is an announcement for the students. If any of your team members have not yet returned, please send them a message to come back as quickly as possible. We will be starting the session now. Good afternoon, everyone. I hope you all had a pleasant break. We will now proceed with our afternoon workshop session conducted by Mr. Chatura D. Silva and Mr. Tarusha Dinujaya, undergraduates of the Department of Computer Science and Engineering, University of Martwell. May I invite them to begin this session?
Hello. Can you guys see me? So everyone, I need your attention. So can everyone see me? Have everyone spotted me? So now we are going to move on to something new. So earlier today, you worked with some embedded system stuff, some simple stuff with Arduino. So we gonna make it a little bit more interesting, right? So I hope you'd enjoy this session. I know like make it too and learn something new and interesting. Are you ready? Okay. So again, I'm going to start now. So the presentation is ready. So keeping in mind what you learned earlier today, just think about this concept. What if like everything around you could talk? So again, I need your attention. You have to look at the slides and also as well as me. So what if everything around you could talk to you? What if your water bottle right next to you could tell you that the water is uh, somewhat lacking and you have to refill it? And the plant you planted in your home could tell you or message you or whatever and tell you that it needs water or it's going to die. Or else in your classroom or here right now, if it's getting too cold, what if the room itself can tell you it's too cold and also like turning off the AC or balance it off? It's amazing, right? It's cool, right? So that's what we're going to do today. We are putting the first step to start moving on this IoT path. So how we interact with the environment as humans? I hope you all can see the screen, right? So we have some what? Ears, nose, and all those stuff. What do they do? What do they do? මල්ලි අපි මොනවද අපේ ඇස් කන් පාවිච්චි කරලා කරන්නේ? අපිට දේවල් අපි දැන් ඇස කන නාසය වගේ දේවල් පාවිච්චි කරලා මිනිස්සෙක් විදියට අපි මොනවද කරන්නේ? දේවල් දකිනවා.
අහනවා.
හරි. එතකොට අපි මිනිස්සු විදියට, ඒ කියන්නේ as humans, so we have some sensors. We get the information from them, and then our brain is the processing element where we process the things we see. And then we have the last thing, which are our legs and our hands. So for an example, I see something. Let's say this guy sees ESP32, I see it. So then I move my limb. Before that, I process from my brain, okay, there is an ESP32. Then I could just go and grab it. So can you see the process there? I saw it, then I processed it, then I act upon it. So this analogy is very important, right? Moving on. So these are the three main steps: sense, decide, and then act. Then a small thing, how we interact with the computer. We go in front of the machine and then we use the keyboard and the mouse and we tell what we need to get done using both keyboard and the mouse. And then there's the system unit, which consists of the CPU. It will process whatever the instruction given by us, process it, and then what? It will display whatever the relevant info we need in the screen. So is that being smart? Think about it. Yeah, it is efficient and it do most of the calculations without any errors, unlike us. But is that smart? Did it sense anything from the environment? Or other than just displaying, did it do anything special on the environment? Did it change anything on the environment? No, right? So how we could make it smarter? So we are reaching to the IoT concept, right? Can we have the slides back? Okay. So how we could make it smarter? We could make it smarter by using the analogy I previously described. So we gather sensors and then, we gather data from the sensors, perceive the environment from the sensors, more on that later, then we process it. Okay, we process it, and then we act on the environment and change something on the real environment. So again, the analogy is sensing is done by a sensor this time, a digital sensor or an analog sensor, whatever, and not a like organ. When it comes to us, we are using organs. So in parallel, like in the same analogy, we're going to use sensors to sense something. Then the processing elements will be there. It could be an ESP32 or something else. We'll discuss more. Then there is an actuator, which could be an LED indicating For an example, in your house, there is a washing machine, and when it's done, it would show it's done. Maybe a green LED blinking or something like that. So this is the simple idea. This is not the textbook idea or the textbook definition of the IoT, but this is the simple idea. When physical objects or things collect data and send them over the internet to make smart decisions. So we are the one who give them the instructions and make them smarter, but thereafter they will do the process we ask them to do as we want to do. So in a nutshell, what we are doing, we are giving the things in the sense, what you built even in the morning is a thing. So we are giving the things, the superpower of the internet. Okay, are you ready? Are you ready for that? Are you ready? So for an example, I would go for a smart garbage bin. I think many of you may have already heard about that. That's why I chose this example as well. So think of a garbage bin. There are multiple garbage bins, but I am currently talking about one of them. So it has a sensor, let's say an ultrasonic sensor, which detects how much garbage is filled currently in that basket. So then it also has the ability to decide whether it will spill out or overflow within the day. So that's the decision part. And then it could notify the authorities. Let's say the municipal council, they will notify, the bin will notify itself, okay, I'm going to spill out today. You have to collect the garbage from me. So what are the implications of this? There are several benefits, right? One of which is it's automated. So the staff of the municipal council or whatever the staff don't have to visit each and every bin and look and check whether it's filled and remove the garbage, right? So now it's smarter. So the bin says, this bin here, he knows its location. He says, I am filled. You have to like remove the garbage and make me free again. So that's that advantage. So it's efficient and saves time. In addition to that, one of the major benefits that like go unnoticed is the ability to collect data without explicitly explicitly doing it as a human. So what happens is when these beans say, okay, I already got filled. Okay, another bean says 2 days. It's 2 days in sequence, but it's not still filled. So what we could do is when these beans sends the data to act upon, we could save all those data. So after a while, we have a lot of data to work with, which we can come into conclusions from. So for an example, we would know, okay, this area of the town is the area where many of the garbage is being collected or people are gathering. So all of these advantages are there. Slides got stuck, I think. Yeah. Anyways, so from that large scale example, I'm going to a much simpler one. So here we are talking about a smart classroom temperature monitor. So there is a sensor called DHT11, which you would be able to spot on your kids, even kids. Try whether you can find it. Okay. Have you all been able to find it inside your IoT kits? Yeah, great. So then there is the brain part, which does the processing. And also in this case, so the sensor gathers the information about temperature and it sends it to the ESP32. It's connected widely. Wired connection is there. Then the ESP32 connects to the internet and provides that data through the internet to a dashboard. So as an extension, I would say we could make it lower the AC level or whatever the action as well. So when the temperature is so low, then the ESP sends a data saying it's too low. Maybe we could make it so that automatically the AC is being controlled to make the temperature rise. So in our case, in the next few slides, we are talking about a simple scenario where we gather data from the sensor, then the ESP sends it to the internet to a dashboard, which will show the current temperature in real time. So can you all see that green gauge here in the act part? So uh, right there. So okay, that's what we're gonna do. So we have the sensor, then the ESP32, then the dashboard. So this will be reiterated and reiterated again because we are going to implement something like that today. So I said here only about a single sensor. So what are the possibilities, right? Is it just the temperature you can do? So it's a lot more than that. So these are some of the examples. I'm not going to go through each one of them. When you are doing an IoT project, according to your requirement, you have to do some research and find out what suits your need or requirement. It could be a temperature sensor, or it could be an IR sensor, or it could be an LDR, which changes its resistance according to the light present, or it could be a gas sensor. You may need to identify a specific gas. So that's there. These all are analogous to our organs, which will sense something we want to sense from the environment. Then there is the brain part or the processing part. So here, don't get it too hard or like think it's very complex. So all I want to say is these are the processing elements we have, like kind of analogous to our brain. So this ESP32, I think you all are familiar. You all worked with today, and you will be working on it. And again, there is Arduino Uno, which is kind of the beginner-friendly version, which many people prefer to use to their first IoT or embedded project. And there are other series as well. So what makes them different is uh, there are multiple differences. There are how many pins are there, what it could better fit, what your requirement. So you have to pick up on that. And also another thing is these two, the Arduino Uno and ESP32, are usually beginner friendly because we can program them with the Arduino interface. Some of the others are also possible to do that as well, but that's the case. So have you got the overall idea, or is it still kind of a black box? Clear? හරි. ඊළඟට තියෙනවා අපේ actuators. So the third part, so which is analogous to our and the legs. So what they do, they make changes in the actual environment. So as I said, there could be a rice cooker that glows in red, or there is a red LED saying it's still cooking. And when it's done, it says it's done by turning on a green LED and switching off the red LED. So that's an indicator. So that's how you know it's done. So LEDs can be used as that kind of an actuator. So it's an indicator. Then there is servo motor, which will precisely let you control something. You can give how much you want to rotate, and it will do it exactly as it is. Then there is a DC motor. So in the example I earlier got, if we think it's not AC and it's a fan, basically you are controlling a motor, right? So that's it about the actuators. I think we could move on. So, Mali, I think there is a problem with this script. Can you fix it? So in the meantime, so as I said, everything around you could talk, right? That is the idea. So if everything around you could sense just like you, your water bottle can hear you. If you put a camera on it, it could see you. So is it all good? This is a side we have to pay much attention to when we are developing IoT solutions, even embedded stuff as well. So it's much more crucial when it comes to IoT because you are working with the internet. So the gold word here is the security. So today we are not, in the practical session, we are not much focusing on the security aspects of things because we need to just get started and do some IoT work. But you have to, as future engineers, you have to keep in mind, security is a crucial thing. You don't want your smart door lock to be opened by some stranger and someone getting in your house. Also, you don't want your smartphone camera to be hacked and someone to be looking at you through your camera. It's disastrous, right? So that's a crucial aspect as well. Okay, getting back to our IoT solution, our beginner-friendly IoT solution, the temperature sensor and the ESP32 and the dashboard. So when I earlier said that we are sending the temperature data through the internet, exactly how we could do that. So here's the answer, right? So we need to be able to gather sensor data from the sensor. Then whatever the way we use, we have to pass it to a dashboard to show it on real time way. So this is the solution we are going towards. Can you all see the board? Okay. So MQTT is the solution we're going to use. So first, to make it simple, I would just use a simple analogy. Let's say this guy here is a newspaper publisher. So he publishes Lankadipa, let's say, okay? Then this guy here, hello, this guy here is the one who distributes newspapers. So whatever the publisher has to give it to, what's her name? Seneru, and Seneru will publish in the sense, he will hand over to the people who requested the particular newspaper from him. Let's say these two are just guys in the home. He needs Lankadipa and this guy needs Dinavina. Okay, so these guys ask him to hand over those newspapers whenever they are available. So daily they will be available. This guy publishes the Lankadipa and he handovers in bulk to him, and he will. So that guy is the Lankadipa guy, right? So he will give the Lankadipa to that guy, and he will not give Lankadipa to this guy, right? He will give the Dinamina to this guy. So that's the analogy there as well. So can we move back to the slides? So here in this case, our ESP32 is kind of like this guy. So he is sending temperature data. He reads the temperature and sends it. Okay. Then there is the MQTT broker, the middle part, the mosquito thing. He is this guy. So what happens is he gets all of them. And the dashboard is one of those guys where they have asked for those temperature info from the broker. So he knows what to do. He gets the temperature info from the ESP32 and then hands it over to the dashboard. Is it clear now? Okay. Is it clear? Can you guys just raise your hands if it's clear? So are there people who still not get it, right? Are there anyone? Okay, great. So you may find out more about MQTT after going home, right? You have to search it and find some stuff, what's it actually doing, how it works. So this is quite a bit more complex example to explain the how the MQTT behaves. So don't mind if you don't completely understand this. It's okay. It's quite complex. So here is a publisher. So this is a sensor that measures some measurement, let's say, on soil. And when it's moisture here. So if the moisture level is low, it will send that as a notice to the MQTT broker. Okay. Then there is a subscriber here, which is again analogous to these guys. So they are already requested any data about the low moisture levels. So the MQTT broker, when he receives any data from this side, he will send it to this guy and also to this guy because he is subscribed to. He is also asking for low moisture level. Then there is another thing happening. So this guy, in addition to being a subscriber who asks for the data about low moisture level, he also can command or send some data about the water pump. So he can make the water pump turn on or off, let's say on or off. So he could publish that data here. And again, MQTT broker looks up data. So there is a subscriber here. So this guy asks for any water pump turn on, turn off information. So if you look closely, you could see there are two types of arrows here. This is marked as one is a one type. It's like a Lankadeepa. So this is the Lankadeepa, let's say one. And there is the second, which is, let's call it's Dinavina. So it's like that. We call this in the MQTT environment as topics. So these three is a single topic. And then these two is another topic. So when you are subscribing or publishing to whatever the data, you say what channel you want or what topic you want. So you say, I want the low moisture level as a subscriber. So MQTT will send you that. Here, the moisture sensor will say, I want to send the low moisture level signals. So this guy will be publisher the channel or the topic called low moisture level. Is it clear? Again, guys, I need you to raise your hands if it's clear. Okay, great. Let's move on then. I think the remote isn't working. Can someone just manually move it to the next slide? It's okay. Make sure whether it's the next slide. Yeah, you have to go back. Again. No. You have to go back to where I post. Just give me a minute. Okay. So I still need you to listen to me and comprehend what I say because you are going to implement something amazing today. Let's say whether this works right now. Okay, it works. So we solved one problem, right? Now we know how we could send the data to the dashboard. So the next problem is, what is the dashboard we are talking about? Can ourselves build it from scratch, like an entire dashboard which shows a gauge in real time that shows the current temperature from the sensor? So this is the answer we are going into. So Node-RED is a given solution to us. It's already installed on all your laptops, I think. If not, please let us know in the next phase. So what happens there is, you almost like do not have to have any coding experience. So it's just like a flow-based system, which I will touch it more on the next slide. So the idea is, your coding knowledge is not that important. All you need is to understand how the flow works, how you should get the information from an MQTT server and then process it and show it to the gauge. All are done through a graphical interface. So it's basically like dragging and dropping. So as you can see here, there are nodes here, multiple nodes that does multiple things, which you may need according to your requirements. So here, if you see, I don't think it's that much clear, but this is an MQTT in, I think. So what happens is, you could get data from an external source, whatever the source, and then process it as what you like. So here the data is uh, gathered from here, then it's being passed here, here, and then to the node end. So there are input side of each node, and there is an output side of the each node. So here the input node is not like an externally shown because it's an encoded in. So you are basically getting data from the internet. So that's why there is no left side trail here. Okay, so the right side of things, as you can see, are mostly like gauges and charts and all those stuff. Again, you gather the data, you process whatever the way you want, and then you show it. Node can do many things in addition to that, but for today, I think this is enough. But you are encouraged to find more later. So these are some of the useful nodes. So I earlier showed what a node look like, right? These all are, this is a node, this is a node, this is a node, and all those are nodes. So these are some of the useful nodes that you're going to use today. So as I said, there is a thing called MQTT broker. So you're going to use MQTT nodes for handling that. There is an MQTT in and out. So in is for gathering information from the internet. In other words, from the ESP32, the ESP32 sends data. So how you get is get that data is using an MQTT in, and there is an MQTT out, which could be used to do the other way around. So you could send data to an ESP32, whatever the thing or the device, through the dashboard as well. Then there is the debug node, which is being used to debug basically. So let's say the MQTT sends some temperature data. Let's say it's 23, but there is no way you could see whether it's working properly and the 23 is the value being passed. You could see it on, let's say in your embedded setup, there is a display that shows it's 23, but you want to make sure whether it's 23 here as well, whether it's passed correctly. So you could use a debug node for that, which in return will show you what is the exact value. Then there is this gauge and chart. These are the UI nodes, which will be used to make a dashboard that looks like, I showed it earlier, right? Let me go back to that again. Yeah, so this is a gauge. And there are charts as well. So all those stuff are drawn just by dragging and dropping those UI nodes. These UI nodes, okay? So then I said you that this noded thing required very minimal coding knowledge, but not zero, right? So here's a reason. So there is a function node, which you could use to implement some custom logic using a programming language. I think it supports JavaScript. So you don't have to worry about that much. Currently, you could just work with these, and if any involvement of this node is happening, the code will be provided to you. So you don't need to worry about that too much right now. Yeah. So yeah, here guys. So I think we are ready to start the challenge. So we are going to implement what I said earlier. So for that, to continue the thing, I will hand over to Tarush.
Yes, Chatur. Before starting, I just want to know how many of you would like to work with IoT. Please raise hand. Those who love to work with IoT. IoT එක වැඩ කරන්න කැමති කට්ටිය අත උස්සන්න. ගොඩක් ඉන්නවනේ. Okay, we can start. First, you have to download the repository. So please type the URL. And I think mentors from 23 batch can help with the download. So guys,
The 23 people, you could help the groups to make it work. And if groups like you guys need any help, just ask someone with the blue shirt. They will help you. මේ බ්ලූ ෂර්ට් ඇඳගත්ත කට්ටිය ඔයගලන්ට හෙල්ප් කරන්න ඉන්නේ. ඒගොල්ලෝ යද්දී ඔයගලන්ට මොකක් හරි ඔයගොල්ලෝ ස්ටක් වෙලා නම් ඉන්නේ කතා කරලා අහන්න කිසි ප්‍රශ්නයක් නැහැ. So 23 people, what you have to do is like you have to download the zip file from the GitHub. Or if there is Git, you could clone it too. It's right. Oh, it's all right. Then you have to go unzip it if you download the zip, and then go into the project root, and then there is a code one. There is a folder code called code one. Go into it, and then open the code file there. There is the Arduino project we are looking for.
For those team who finished with download and unzipping, please raise hand.
So again, come on. You all done? Okay. Is there anyone who are stuck and need help? Is there anyone?
For those who download the zip file and unzipped it, please open code 1 INO file. I think you got already installed Arduino IDE.
So there seems to be people who are familiar with command prompt as well. Huh? Really nice. Oh yeah, also Linux. You have to go into the code one folder and then open it with the Arduino IDE.
In meantime, those who completed the task, you can install PubSub client in Arduino IDE. There's a library called PubSub client. Uh, I will share the screen and show you how to install it.
ओपन करके ना तीन नहीं हरी कमांड रेडी करना है नहीं हरी
For those who already downloaded the zip file, you can go to Arduino IDE and install PubSub client. There is a library called PubSub client.
harus ini harus Ay, kan कर ये वीडियो के लिए मैं उधर लंग कर लगा मैं के लिए मिग्रेट
Uh, Guys, you have to hurry up. We are running out of time. So install the library PubSub client.
So again, I am repeating, when you are done unzipping the file, downloading and those stuff and opened it from the Arduino IDE, what you have to do next is install that library, the PubSub client. If you are not clear about that, please feel free to ask from whatever the guy around you with the blue shirt.
And also you have to install the DHT sensor library published by Adafruit. You can see the left side of the screen, the library, DHT sensor library. Guys, raise hand those who complete the library installation.
So guys, hurry up. Can you hear us? If you are done installing the PubSub client, please raise your hand. If you are done installing the PubSub client, so you are all done. Up to date with us. Hands up. Okay, so there are many people remaining. Okay, we'll wait some time. So the challenge is not just to build an IoT device, right? It's to finish it on time. So if you are stuck at somewhere, you have to just ask for help. Move faster. They will help you to understand as well as to set up the thing. So don't hesitate to ask someone around you with a blue shirt.
And Chatura, I think today these guys are measuring temperature without having a thermometer. What do you think? Thermometer එක නැතුව temperature මනින්න. So let's ask about them how they feel about it. So Mali, IoT වලට කැමතිද? මොකද්ද reason එක? ඔය මොකද්ද මුලි?
මනුෂ්‍ය
Okay. IoT වලට කැමතියි. හේතුව
ඒ දේවල් අපිට මේ ඉතලා අපේ own creations කරන්න පුළුවන් ලේසි අනික මේ කෝඩ් කරන්නේම ලේසි ගොඩක්
එතකොට මම කියවස් දෙන්නේ. හරි අපි අද බලමු ඔයගොල්ලෝගේ පළවෙනි IoT project එක අද කරනවා. අපි බලමු. I think most of you have done with the installation part. Please raise hand those who already completed the installation.
Okay, let's change the plan. Please raise hand if you are not yet up to date with us. If you still are to install that PubSub client, or if you are still downloading the zip file or whatever, if you are not completed yet, please raise your hands. Otherwise, we're going to move on. So attention, please. If there is anyone still doing the task and not completed the task up to us, so who are still not yet installed the PubSub client, please raise your hand. I think I don't need the mic right? Anyone? So we got to yeah.
I think we can move on. Okay, guys, we have set up a circuit here. I think you already got a component box. Guys, we can move on with the circuit part. So, Uh, Guys, we can move with the circuit part. So all you have circuit component box. So this is DHT11 sensor. This one you can measure. There is a component light blue color. Please pick up that component. This one. This is DHT11 sensor. We can measure both temperature and humidity using this sensor. So in this sensor, there are 3 pins. You can clearly see two pins are named with VCC for power up the sensor, and G and D is for grounding. And the pin between the ground and VCC, that pin we use for taking the sensor reading. So you can take a breadboard given to you. Guys from 23 batch, please help them to set up the circuit. Uh, in ESP32, we use pin number 23 and pin number 4 for taking data. Two pins used for ground and 3.3.
So again, any of you guys have any confusion about the numbers being used? Please ask. Please ask us. We will read what are the pin numbers being used.
If you guys connected the DHT11 sensor, you can see there is a bulb. It will be light on.
So if you guys were not clear about how the components are connected to each other, now you can look at the board. And it's more explicitly stated on a different diagram with the breadboard.
When connecting pins, make sure to not to short circuit the 3.3 and ground. those who have done the circuit part, you can open Arduino ID port number 1. Uh, those who completed the circuit part, please raise hand. Yeah. Keep raise your hand if you have completed the task.
So the people who completed the circuit, who have connected the things, please raise your hand if you are all done with the circuit. So we need more winners. Aren't there anyone who have completed already the circuit assembly?
Raise hand.
Okay, you can lower your hands.
Raise hand. Raise hand. I think
So everyone, so stop your work now. I just want to know where you are currently at right now. So stop your work and just give me the attention. Just stop whatever you are doing and look at me. Guys, come on. හරි. තාම සර්කිට් එක සෙටප් කරගෙන වැඩේ ඉවර නැති කට්ටිය ඉන්නවා නම් අත උස්සන්න. තාම සර්කිට් එක සෙටප් කරගන්න කට්ටිය ඉන්නවා නම් අත උස්සන්න. තාම ඉවර නැහැ. රූප් 1යි 2යි 3යි අත්තන 1යි 4යි 5යි එච්චරයි දින්නේ. මෙතන ඉන්නවා 6යි. මේ ගෲප් වල හොඳට අත උස්සන්න කට්ටිය ඉවර නැති කට්ටිය. හොඳට අත උස්සන්න. ඔයගොල්ලන්ට හෙල්ප් එකක් දීලා ඉක්මනට ඉස්සරහට ගන්න හදාන්නේ. අත උස්සන්න. හරි 23 බැච් එකේ නම් ඉනවල්ල පොඩ්ඩක් සපෝට් එක දෙන්න මේගොල්ලන්ට. ටක් ගාලා වැඩේ ඉවර කරගන්න. තේරුම් ගන්න කම්ප්ලීට් කරන්න මොකක් හරි කියනවා කියලා රැන්ඩම් දේවල් අවුලන්නේ අර කුසල දේවල් වල So is there any team who haven't yet finished and also did not get any attention or help from the seniors here, from the blue shirt guys? Is there any team who need help and not yet received any help? Okay.
Guys, you have to wait until we are opening the node RED. First, you have to make sure the circuit is working. Otherwise, you can't connect it to the internet. So, guys, you have to wait until we introduce node RED. First, you have to make sure circuit is working.
So again, I'm going to get an update. So who are the ones who are still doing the thing, still wiring the circuit? Okay, one team is there. Is there anyone else? Okay, raise your hand. If you are still not completed, just raise your hand. Okay, I see one team here and two. Is there anything? Any more teams? Three teams? Okay, four. Is that all? One, two, three, and four. Okay, you guys are there too. Okay.
Guys, please raise hand. You are still doing the circuit thing. Chatura, there is something. Guys, please raise your hand if you are still working on the circuit part. I only see there are two teams. Is there any other team? And
So it seems like some of you guys are so much curious that you are thinking about why the hell there is a bulb. So LED bulb is for the next exercise. Just ignore it right now and just connect the things as displayed and just go along with us. The LED bulb is for another exercise. Just don't think about that.
It seems like all teams have completed the circuit part. Those who have not completed the circuit yet, please raise hand. Yeah. Uh, yeah, I think we can move on. So now, guys, open code one Arduino INO file. Uh, in Arduino INO file, you can see there are three variables called SSID and password and MQTT server. So in here, SSID means you have to uh, connect ESP to internet. There is a middle one like router to connect internet. So in this case, we are using mobile hotspot to connect internet. So mentors from 23 batch. Yeah, I think you can see it right now. Uh, mentors from 23 batch will provide you Wi-Fi key and Wi-Fi username. So ask them about Wi-Fi password and username and change your code. Uh, uh, guys, you have to change here SSID and password. Do it quickly. Guys, have you done the code change part? Update your code with Wi-Fi username and password.
So 23 people, hello, 23 people, you have to turn on your hotspots and allow them to connect to them. They need internet. So if there is anyone in the groups where they don't have any internet connection, you have to provide them through your mobile hotspot. Please work on that.
You guys just have to change here SSID and password. Guys, you have to only change the SSID and password.
So when you are done wiring the circuit and when you have opened the code one file, in the code one file, in the first, I think the line 8, 9, and 10, you have to change the SSID and the password. So you have to connect to a Wi-Fi hotspot. So for that, you have to change the SSID and the password. So the line 8 and 9. If you don't have any internet connection, just ask a blue shirt guy. He will give you an SSID and a password.
Rice and those who completed that too. In code 1, you have to change another thing. Guys, attention please. Yeah. Those who still working on SSID and password, please raise hand. Yeah, it seems like all have completed it. So then we have to and you have to change another line in code 1. In code line 55, you have to change the topic. In here, it is SLIoT slash topic 1. You have to enter SLIoT slash team number. Like we can start from there. So the team corner, you are team 1, team 2, team 3, team 4, and the corner 1, teams, there are 5, 6, 7, 8, 9, 10, like that.
Okay. Let me take your attention. So please, we go on a number the teams. So team 1 is here. Guys, raise your hands. Team 1. Team 2. Team 3. Team 4. Right around the corner. Raise your hand. You are team 4, right? Then, is there any team there? Okay. Team 5. Team 6. Raise your hand. Team 7. 8. 9. You guys are 9. You have to raise your hand. Team 9, okay? Team 10. 11. Who are the team 11? So, then the team 12 are you guys. You do, yeah. 13. Then 14. You three are separate team, right? Are you guys a separate team from? Yeah. So what is your team number? Ask them. Yeah, 14. So you guys are 15. Team 15. You three. Team 16. Raise your hand when I say your team. Team 16. 17. Hello. Raise your hand. 17. 18. 19. 20. Did I miss you? 21. 22. Again. Team 19, raise your hands. 19. Team 20. Team 20. Okay, is there a team 21 yet? Okay, team 21. 22. You guys are 22. These guys are 22, okay? Okay, 23. Okay, 24. 24, raise your hand. 25. 26. And 27. Is there a 27? Yeah, 27. If you are not clear about your team number, please ask a blue shirt guy or me.
And you have to change the topic SLIoT slash your team number. Please do the change.
So for an example, let's say I am team 50. So I'm going to change the topic to team 50. If you are not clear, just look at this. So currently it's topic 1 and I change it to 50 because I am team 50.
After that, you can compile and upload into the ESP32 board. After uploading, you can open serial monitor. You can access serial monitor through audio ID. I think you can see the shared screen. By pressing this icon, you can open the serial monitor. In top right corner, there is the icon. You can press it and open the serial monitor. If you need any help, you can contact nearby 23 mentor.
So is there any team who are up to date with us and currently have opened the serial monitor and got this MQTT connected and Wi-Fi connected thing? Is there any team who are up to date with us? Hello, is there any team who have done all the stuff we have asked and currently have this serial monitor open and connected to MQTT? Any team? Raise your hand if you are done. Okay, I see one team, 2, 3, 4, 5, 6. Great, great, great. There are 7 teams. Okay, come on.
Guys, we can move on. So guys, if you have completed the uploading and got the result in serial monitor, open a terminal in your computer. Go to search bar in start menu and type CMD and press enter. After opening the terminal, enter node minus mark red and press enter. Node minus mark red, enter.
So the 23 people, please help them to open the Node dashboard. You have to go to the command prompt of the terminal, whatever the terminal, and type node dash red. Please help them to get that thing open, the Node dashboard.
In terminal, there is a link. So you can press it and open the Node dashboard in your browser. Is there any issue? Please raise hand. You should be able to get a dashboard like this. Guys, Node එකට අවුලක් තියෙනවා නම් කවුරු හරි අත උස්සන්නකෝ. So in Node-RED, there are two panels. In left side, you can access the node. There are multiple nodes you can see. You can basically drag and drop each node. So in our case, we are trying to monitor temperature in the dashboard. So we need to get the temperature from the ESP32. So we are using MQTT broker. So we should have a MQTT in. So the purple one, MQTT in. Drag and drop it in your workspace. There's a MQTT node in left panel. Drag and drop into the workspace here. Thereafter, we need a debug node. So there is a debug node, the dark green color. Drag and drop like that. Thereafter, you can connect those two nodes using a edge like that. Start with MQTT in and end with debug node. So I will zoom in here. Okay, double click on MQTT node. So there is a pop-up tab. And here you should be able to scroll down, and there are no mosquito or something in drop down in your space. So just select add new MQTT broker, and there is a pencil for edit. So in here you have to enter the server name and port. So I will give you the configuration. In server section, enter test.mosquito.org. ඒකේ ඉන්පුට් එකක් තියෙනවා. ඒකේ සර්වර් කියන පාර්ට් එකේ ඔයගොල්ලෝ ටයිප් කරන්න test. Guys, attention. So I will start it again. So first double tap on MQTT node. So you should be able to get a editor tab like this. And in editor tab, there is a field called server. In server, there is a field called add new MQTT broker. Select it and press edit icon. So there is a editor tab for MQTT broker. In this field, I will give you the configuration for your part. So here for name, enter mosquito. And for server, it is test.mosquito.org. And it's on port number 1883. And keep the other configurations as it is. Those who completed this and updated the mosquito and server, press the update button. So you should be able to select mosquito from drop down menu. Guys from 23 batch, please ask them, is there anything goes wrong? So I will repeat it again. You have to select add new mosquito broker and press edit button. In this window, you can see there are a lot of inputs, but you have to change only 2 inputs. First, the name section. In name section, you have to enter mosquito. In name section, enter mosquito. And server section, enter test.mosquito.org. And port, it's 1883. I think it's a default port. Please make sure the configuration is right. The guys who have done the mosquito saver configuration, please raise hand. I just want to see how many teams have done it. Yeah, there are 2, 3, 4, 5. So, guys from 23 batch, please help others. So, after that, you have to enter your topic. Like, as I said before, SLIoT slash your team number. In this case, I enter SLIoT slash topic number 1. Here. In topic section, enter SLIoT slash your team number, as I said before. If you have done with the topic changing part, you can press the button, the done. After that, you can deploy your dashboard. Press the deploy button in right corner. I think you can see right now. This one. You can deploy your dashboard. And they ask about confirmation. You can confirm and deploy. And you can see the dashboard here. After deploying, there is a icon with bug like this, debug messages. So press it. You will be able to see the temperature sensor reading. Oh. I will repeat the process again. First, you have to pick MQTT in and a debug node and connect them using a wire. And after connecting, double click on MQTT node and create a server. You have to update the name, server, and the port. After entering the data, you can double click on update. And thereafter, you have to update the topic. For topic, it is SLIoT slash your team number. Update it in the topic section. Thereafter, press done. And after you update it, deploy your server. There is a red button in right corner, right top corner. Press it and deploy. Thereafter, there is a button for debug message. Press it and you will be able to see the temperature reading. Thereafter, we are receiving the temperature reading, and we can show it using a Gojo chart or something like that. So to that, we need a dashboard. For creating dashboard, uh, there is a tab and link section. In that section, there is a button called tab. So it will create a tab, and there is a edit button in the tab section. So press it and you can edit the name, make it workshop, and update. In that tab section, there is a button called group. Create a group. First, you have to create a tab. Then you have to create a group. Select edit button on the group and change the name to temperature. Thereafter, you can pick gauge or chart. I pick gauge here and connect it to the MQTT in Node and double tap on gauge. In gauge, there is a drop down menu called group. Select the group that you have created before. In this case, it's a workshop temperature one. And for max value, we are reading a temperature. In that case, we can have a range 0 to 50. And press done. So after that, you can deploy your project. In Node dashboard, there is an icon called C dashboard, the corner one. So it will open the UI like this. You might not have this kind of UI, so it looks like this, something like this. There's a button, layout, site and theme, and the corner one. You can press the corner button and open the UI. I will repeat the Gauge updating part. Double tap on Gauge. In Gauge, there's a drop-down menu called Group. In that drop-down menu, select the group name that you have created. So In this case, it's a workshop temperature. So I select it. And there's another range, another field called range. And you have to pick values for min and max. So in this case, I select max 50 and min value is 0. And after updating that fields, you can press the done button. For accessing the dashboard, there's a button in the corner. Press it, and it will open your dashboard. So it should be look like this, something like this. So in the dashboard, you should be able to see the temperature reading.
So are there any people who got the temperature reading? So in this case, this is not working due to some error, but are there, I saw some. Is there anyone who was able to get the temperature reading to the dashboard and preview the dashboard? Like it would be something like 24.1 or something. Are there anyone who was able to get that? I just saw. There should be people who were able to get the temperature reading from the sensor to the noted dashboard. So please raise hand. Raise your hand. Oh, it seems like there are no any. හරිද? ඔගොල්ලෝ ඉවරයිද? Okay, now I'm asking again. Is there any team who have finished the thing and got the noted dashboard to work and show your temperature sensors reading? Raise your hands. Raise your hands. I know now there are a few teams who have done this. Okay, there is a single team here. Is there any others who was able to get the temperature reading to the dashboard? I saw some teams has done that. There is another team. Yeah, raise your hands. Others should know. Raise your hand. Okay, there are two teams. So okay, there are three teams. Great, great, great. So we have the first place, second place, and the third place, right? We have three teams who have done the thing. So is there a four as well? No. One, two, three. Okay. Anyways, so with the time constraints, we are going to stop the session now, but you don't have to worry whether you got stuck at somewhere and not being able to finish the thing. You don't have to worry. What we're gonna do is we're gonna provide you with the instruction and the code base and everything to you to proceed by your own after the session at the leisure of your home. So I think we could wrap up the session right now. Can someone from the OC take the charge?
Thank you, sir, for the very interactive session. We will now move on to the Q&A session of the competition segment. This is your opportunity to clarify any doubts and engage actively. You are welcome to ask your questions in English, Sinhala, or Tamil. Kindly convey your questions to the team coordinators. Team coordinators, I would like to ask you to collect the questions from your respective teams.
හරි මේ අපි සෙෂන් එක අදට ඉවර කරන්න යන්නේ ඊට කලින් ඔයාලට පුළුවන් මේ ඔයාලගේ මොන හරි questions තියෙනවා නම් ඔයාලා ඔය ළඟ ඉන්න OC member ට කියන්න. එතකොට අපේ OC එකේ members ලා සහ අද session එක කරපු අය ලෑස්තිලා ඉන්නවා ඒවට answers දෙන්න. ඔයාලට තව විනාඩි 5ක් වගේ හම්බ වෙනවා මේ question and answering session එකට. ඔයාලට ඕනේ තියෙන question එකක් අහන්න competition එක ගැන questions තියෙනවා නම් ඒවත් අහන්න පුළුවන්. හරි ඒ වගේ තමයි මේ අද මේක කරන්න බැරි වුණා අපි අන්තිමට සෙෂන් එක කරපු සෙෂන් එක හරි නැත්නම් ඊට කලින් කරපු සෙෂන් එකේ හරි කරන්න බැරි වුණා ඉන්නවා නම් එයාලට ඕනි ඉන්ස්ට්‍රක්ෂන්ස් ඔක්කොම ටික අපි ඔයාලට WhatsApp group එක through දැනුවත් කරනවා ඒ නිසා ඒක ගැන අවුලක් තියාගන්න එපා ඒ ටික ඔක්කොම ඔයාලට ඉස්සරහදී හම්බෙයි
Attention, please. This is an announcement for the OC members. I would like to ask you to please collect your questions and convey them to be answered. Attention, please. Those who were not able to complete today's workshop, all the instructions and the slides will be available to you in the WhatsApp group. We will be sending them. Attention, please. OC members are now required to collect all the kits from the tables. Students, you are advised to stay in your seats until the OC members collect your kits. Attention, please. Students, please remain seated.
මේ ස්ටඩන්ස්ලට මේ නස්මට එක ඔයාලගේ සීට් සලම ඉන්න මොකද මේකෙන් පස්සේ යනිවටුව එකක් තියෙනවාලට ඒක රේංච් කලතින් අපි කිට්ස් ටික හරියට කලෙක් කරගන්නකං සීට් සලම ඉන්න.
Attention, please. Attention, please. OC members, if you have any of your personal laptops, please bring them to the front desk. Attention, please. OC members, I would like to ask you to please speed things up.
මේ OC එකේ members ලා පොඩ ඉක්මන් කරන්න අපිට වෙලාව නැහැ. ඉක්මනට ඔයාලගේ laptops තියෙනවා නම් tables වලින් collect කරලා මෙතන අරන් එන්න. kits තියෙනවා නම් ටක් ගාලා collect කරගන්න. තව විනාඩි 2ක් වගේ තමයි ගන්න පුළුවන්. හරි අර අරකට වීඩියෝස් ගන්න විතරයි. ඒකට එක හරි.
Ladies and gentlemen, as we come to the end of today's workshop, it's time to conclude what has been a very insightful and engaging program. We would like to express our sincere gratitude to our speakers for sharing their valuable knowledge, experiences, and guidance with all of us today. Your contributions have truly inspired our students and provided them with meaningful direction for their future innovation. Now, to formally deliver the vote of thanks, it is my pleasure to invite Dr. Kutila Gunasekara, Staff Advisor of SLIoT Challenge 2026, to address the gathering.
Thank you. Good afternoon, everyone. I suppose everyone is eager to go home. So I would like to take just 2 minutes to thank, first of all, the resource persons from the 21 and 22 batches of Department of Computer Science and Engineering. I know you all are busy, some are on training, some are in their final year with their projects. So thank you very much for your efforts. We really appreciate it. Second, I would like to thank SLT Mobitel, our sponsor. Yeah, I'd like to thank SLT Mobitel, who is our sponsor for this event, and Mr. Ayoma Vikramarachi, the Deputy General Manager for Broadband, and his team. And then I'd like to thank all of you students who have come from all over, well, close by and very far away around the island, who have come here. So hopefully you got something positive, and we'll be seeing some exciting products from you all in the next rounds of SLIoT Challenge. And I would also like to thank the guardians, the parents and the teachers who accompanied everyone and spent your Saturday here. So thank you very much for that. And Also, I would like to thank, I think, finally, the organizing committee, the people who worked really hard behind, some people are not here. They are all from the 2023 batch of the Department of Computer Science and Engineering. So they worked really hard. We had quite a number of challenges compared to last year's. So really appreciate your work, what you have done. Thank you very much, everyone. And of course, the CSE department staff, including Professor Chandana Gamage and everyone who supported us. So that's it. Thank you very much, and all the best to you all in the rest of the competition.
Thank you, sir. Before we officially conclude, we are pleased to invite you all participants to join the university tour scheduled next. This will be a wonderful opportunity for you to explore the campus environment and experience university life firsthand. Before that, I would like to make a few announcements. The tour will take about 20 to 30 minutes and it is not compulsory. So if anyone has issues with the timings, they are free to leave. After the tour is over, we will also be taking a group photo. Once that is over, all the students and parents are requested to please go to the walking gate to sign before leaving. Please make sure to sign before leaving. Our OC members will be there to help you through it. Once the parents have finished signing, they can come back to get their vehicles. Kindly gather with the team coordinates with your bags to begin the tour. Once again, thank you all for being part of today's program. We wish you safe travels and great success in your innovation journey. Have a wonderful day.
හරි මගේ ඉන්ස්ට්‍රක්ෂන්ස් ටික සිංහලෙනුත් දෙන්නම්. පළවෙනි මේක තමයි අපි ඔයාලට යුනිවර්සිටි ටුවර් එකක් ඕගනයිස් කරලා තියෙනවා. එතකොට යුනිවර්සිටි ටුවර් එකට ඔයාලට එකතු වෙන්න පුළුවන්. බට් ඒක කම්පල්සරි නැහැ. කාට හරි කෙනෙක්ට යන්න වෙලා යනවා නම් එයාලට යන්න පුළුවන්. බට් ඔයාලා අනිවාර්යයෙන්ම යුනිවර්සිටි ටුවර් එක ගිහිල්ලා ගියත් එහෙම නැතුව ගියත් සයින් කරලා තමයි යන්න ඕනේ යුනිවර්සිටි එකෙන් එළියට යද්දි. ඒ නිසා හැමෝම වෙහිකල් වල ආපු අය සහ අනිත් අය අපේ රෙජිස්ට්‍රේෂන්ස් කරපු රෙජිස්ට්‍රේෂන් ඩෙස්ක් එක තියෙන තැනට යන්න. එතන අපේ OC මෙම්බර්ස්ලා දෙන්නෙක් ඉන්නවා. එතකොට ඔයාලා අර උදේ සයින් කරපු එකේම ඔයාලට සයින් කරන්න පුළුවන් ඔයාලා යුනිවර්සිටි එකෙන් එළියට ගියා කියලා. එතකොට යුනිවර්සිටි ටුවර් එකට ජොයින් වෙන ළමයි එක්ක ඉන්න පේරන්ට්ස්ලාට පුළුවන් එතන වෝකින් ගේට් එකේ එහා පැත්තට වෙලා ඉන්න. ඒක බ්ලොක් කරන්න නැතුව එයාලට එතනින්ම සයින් කරලා වෝකින් ගේට් එකෙන් එළියට යන්න පුළුවන්. හරි අපි යුනිවර්සිටි ටුවර් එක පටන් ගන්න අපි ගෲප් එකක් විදිහට 85 දෙනෙක් ඉන්නවාද එතකොට මෙතන ඒ 85 දෙනාත් එක්කම තමයි යුනිවර්සිටි ටුවර් එක යන්නේ. එයාලට පුළුවන් දැන් නැගිටලා මුලින්ම දැන් යන්න හදිස්සි අයට පුළුවන් ඉස්සල්ලාම යන්න. එයාලට නැගිටලා කවුරු හරි කෙනෙක් යුනිවර්සිටි ටුවර් එකට පාටිසිපේට් කරන්නේ නැත්නම් එයාලා මුලින්ම නැගිටලා එයාලට දැන් මේ හෝල් එකෙන් යන්න පුළුවන්. අනිත් අය සීට්ස් වල හැමෝම ඉන්න. හරි මේ දැන් එහෙනම් යුනිවර්සිටි මම හිතන්නේ හැමෝම ගිහිල්ලා ඉන්නේ. යුනිවර්සිටි ටුවර් එක පටන් ගන්න ඔයාලා යුනිවර්සිටි ටුවර් එක පටන් ගන්න ඔයාලා දැන් පොල්මක් විදියට හැදලා යන්න ඕනේ. මෙතනින් එළියට ටීම් එක ගානේ යන්න. ඊට පස්සේ යන්න එපා. ඔයාලව හැමම පොලිමක් කරලා තියයි. ඊට පස්සේ හැමෝම එකට තමයි යුනිවර්සිටි ටුවර් එක යන්නේ. දැන් අනිත් අයටත් එළියට යන්න පුළුවන් නැගිටලා. OC OC members OC members ලා හැමෝම මේ හෝල් එකේම ඉන්න. කොහෙවත් යන්න එපා.